Well, welcome back. We get to continue talking about some compound inequalities, but we're going to focus on one word. We're going to focus on compound inequalities that are joined together with the word and. Now, before we start this, before you get going on this, I want you to ask yourself some questions here. Do you know how to solve linear inequalities? Because if you don't, you might want to watch a couple videos ago where we talked about how to solve these things. Do you know that these things are treated just like equations? And do you know when we have to reverse an inequality? If the answer is yes, by all means keep on watching. If the answer is no, refresh your memory before you continue because that can get very confusing. Do you know when to use a parentheses and when to use a bracket for interval notation? Does interval notation even make sense to you at this point? If it does, you're on the right track. If it does, this video is for you. If not, watch a few videos ago, get really comfortable with that, and then come back to here. You see, right now, we're not going to spend a whole lot of time focusing on the technique of solving inequalities. That's old stuff. Right now, we're just going to look at this word and see how that affects this joining together of these two inequalities. The goal for this video is, to solve some linear inequalities, but to put them on a number line and then to translate to a solution set that we represent with interval notation. That's the goal for this. So let's think back to what and means. You see, and was this idea of you have both. You have a solution that works in both inequalities, not just one. So anything that doesn't work in both would be outside the solution set. If you remember from the last video, basically what we're looking for is this overlap idea. Almost all the time, well, actually, all the time, if we're going to get solutions for this and inequalities on our number line, I'm going to ruin the suspense here, people. You're going to get this. That's what you're going to get. Always this. If you get this, and does not have a solution, or would, but not and. So we're looking for this for the word and, this interval that crosses over, that overlaps, this double shaded spot. So let's take a look at it. Now, here's the great news. The great news is that in order to solve and compound inequalities, you just need to know how to solve inequalities and do it twice. Basically, we're just going to be solving two inequalities, putting them on a number line, and interpreting the result. So let's get started with it. Hopefully you remember this. You remember that we can treat any inequality, like ever, as a linear equation, which means you basically just isolate your variable by undoing the stuff around it. If you got addition, use subtraction. Got subtraction, use addition. Get rid of your constants first, and your last step is basically divide. That's it. There's one little hiccup, not even a hiccup, it's just something we need to realize, is that if you divide by a negative, no matter what happens, you've got to reverse your inequality. That's the big thing. So let's start here. If we're going to solve this linear inequality, we're just going to be subtracting 3. You see our variables on the left-hand side. We like that. We want to keep our variable on the left-hand side, but get rid of everything around it. If we subtract 3 from both sides, there's no way we should be flipping that inequality because we didn't divide by a negative. All we get is x is less than 5. I'm going to encourage you right now, draw a number line and graph that. So there was one more piece, kind of just advice that I gave you, just a little bit of advice. Try to get your variable on the left-hand side. If you don't, take your inequality off the paper and reverse it so that your variable becomes on the left-hand side. The reason why we want that is because the arrow that inequality makes basically points the direction you should graph on your number line. This only works if your variable is on the left-hand side of that inequality. It does not work if it's flipped around. So this says graph left. You can think about it, sure, the number is less than 5 or to the left of 5. And what should we use? I'm going to make this pretty large to see if we have any overlap. Should we use a bracket or should we use a parentheses? I'm going to look back at that. I know that equals would include the number. Things that do not have the equals, eliminate that number from the solution set. Everything up to 5 would work, but not including 5 for that particular inequality. So we need to maintain that. Basically, these compound inequalities do not work any different. They just say, do we have numbers that work for both? So we ignore this one, solve this, graph this, then look at the next one. Here's some interesting things happen. So yeah, we're going to get our variable by itself, and we treat it just like an equation. So I'm going to get rid of my constant, no problem. Because I didn't divide by a negative, we don't need to flip around any inequalities. Here's where we do. If you ever get down to the last step and you've got to divide, and you say, hey, with division I'm trying to get 1s. The only way that I'm going to be getting a 1 here is if I divide by -2. That's the kicker. That's the one that's going to reverse your inequality. Not that we're getting a negative. I could not care less about that. I don't care that this is -2 over here. I don't care. I don't care that this is positive x. That's what I want. And I love that it's on the left-hand side. That makes things really easy for me. What I care about is right here. If you divide by a negative, it must reverse that inequality. Now, with any compound inequalities like ever, we're going to be doing the same thing. Whether we have and or the word or, which we unpack in 2 more videos. It doesn't matter. We're going to solve both of them. We're going to put them on the same number line. What we're looking for is the way that these inequalities interact with each other. So we're going to look at this and go, okay, I've already graphed x is less than 5. I use a parentheses because I don't have the equals. I'm going this way because my arrow says this way, less than 5, left of 5, arrows on the left. It's fantastic. One big thing, when we graph both inequalities, I mentioned it last video, but it's crucial. You have to put these numbers in order. You can't be putting -2 over here. You've got to follow the rules of a number line, which say that -2 is automatically to the left of 5. Now, I'm going to look at my inequality first. Would I get a bracket or would I get a parentheses? Well, that says include the number. What do we use for that? It's got to be a bracket. And because we have my inequality set up correctly, the inequality tells us I want numbers larger than or to the right of -2. And here's where your reading comes in. Really, all you got to look is between the inequalities and read the word. For the word and, you've got to have an overlap. That's what satisfies both inequalities. And think about it. We did all the solving so that we'd easily see it. All these numbers, listen carefully here, don't miss this, okay? All these numbers this way work for just this inequality. Everything this way, even over here, all this junk works here, no problem. All this junk works here, no problem. What we're looking for is the junk that works in both of them. So if all the stuff here works in this one, all the stuff here works in this one, the stuff between them work in both. That's what and is. And says, what are the numbers that work in both of these inequalities at the same time? That you can plug into both of them and get true statements. Everything that's double shaded. That's the idea of double shading. It says, hey, it works here, oh, stuff in between works in both. That's why we double shade them. So we draw our interval, or we write our interval just like any other interval that we've ever had. Look at the part that works, the solution set. The numbers in the solution set are everything from -2, including that, we get the bracket, all the way to 5, but not including the 5. Like 4.99999 for a long time, sure, but not 5. So our solutions are all the numbers between -2 and 5. Are you seeing the interval notation at work? Are you familiar with that? Do you remember that normally, like if I just had one of them, if I didn't draw the purple line, that inequality would be from -infinity all the way to 5. This inequality would be from -2 all the way to infinity. We're eliminating a lot of that because those numbers don't work in both, and says that we have to have numbers that work in both. You can try them all day long if you really want to. Plug in something like 0. I love 0. 0's in here, it's easy to plug in. Plug in 0. Hey, 3 is less than 8. Plug in 0. -1's less than 3. Oh, it works in both. That's going to happen for all the numbers in between that. That's kind of cool. That's what this is doing for you. That's why we draw a picture too. That's why I made you guys do the number line so that you can see what's going on. That's really the only way to get this stuff down easily, is to be able to draw the number line, make sure that these numbers are in order, if you don't erase them. These numbers are in order on the number line, and that you have your variable on the left, graph the correct direction, use brackets and parentheses appropriately, and your overlap will show you the solution for the and. Let's do one more. I'm going to give you 2 more weird ones after this, some weird things that can happen, and then we'll be basically done. So what I'd like you to do, if you can, I want you to solve this on your own. Maybe pause the video, see if you can do it. I'm going to get going on it right now, but the solving part, man, that should be really, really easy for it at this point. It's kind of nice, just some practice. The interpretation is what's important. You need to be getting in your head what and means on a number line. So we're going to start. Now we know with linear equations, we get rid of constant terms and then we divide. Same thing happens here. We get rid of constant terms by addition or subtraction. Addition or subtraction can never, ever change your inequality, ever. Division can, but only if you're dividing by a negative. We didn't divide by a negative, so we're done. Now, you don't have to fill out your number line right now. Some people choose not to. I really don't care whether you do it right now or not. I'll hang on because I don't know what number this is. So what if I put my 2 way over here and this number's way over there? It's probably not, but we'll just have to see. So, same thing, linear inequality. Let's get rid of constant, use addition, subtraction. Do not forget that that sign goes with that term. You need that. Can you see why you need it? Do you see what that's going to do right now? If you forgot that, your inequality is going to be all jacked up, all right? But if you get this, and you divide by your negative, oh, listen to what you just said. I'm dividing by a negative. I don't really care that that became negative. What I care about is that you divided by a negative. That must reverse your inequality. Now, at this point, you can graph both at the same time. Just put your numbers in order. So if I'm looking at 2 and -1, I know that over here has got to be -1. Hey, I know my variable's on the left-hand side. It looks fantastic. I know it's aimed to the right. I know that I'm going to use a parentheses because I do not have an equals. Is this making sense to you? Are you getting that? Going to the right. Here, I know that 2, I'll use a different color pen, just so I don't get confused. 2 is to the right of -1, but this is asking for all the numbers less than or equal to 2. Less than or equal to 2 is this way. The overlap for the word and is what we're looking for. We're looking for all the numbers that satisfy both this one and this one, that are both less than or equal to 2 and at the same time greater than -1. Well, that eliminates a whole bunch over here. These numbers are just less than 2. These numbers are greater than -1. These numbers are both less than 2 and greater than -1. This interval that's double shaded, that has solutions to both inequalities, the numbers that work for both inequalities, is from -1 to 2. Do you remember that intervals have to be from left to right? We can't write 2 to -1. We've got to write -1 to 2. It's got to be in order. Number lines are always in order. Therefore, intervals are also in order. Now, I told you that we're going to do a couple kind of weird ones that sort of trip students up a little bit, so we're going to talk about that. But before we go on, I want to do a little 10-second recap. The only thing that's really happening is you're doing these linear inequalities, you're graphing 2 of them. With and, you're looking for crossover. That's about it. Let's try 2 more. If you want to try that one as I'm writing the next one up there on the board, feel free. Let's see if you can identify the weirdness, like what in the world is going on. That one too. So we're going to get going on. We're going to solve these, man, no matter what. If you get a linear inequality, you're going to be solving it the same way. The only thing you got to worry about is dividing by a negative. Hey, keep your variable on the left-hand side. If you divide by a negative, just flip around your inequality. No big deal. What we're looking for is the connection on the number line here. So let's look at this. Don't let that confuse you. This is not like a no solution sort of thing. This is just a linear inequality, and the only thing you have to do is get rid of that 4. If it's connected by multiplication, you'd be dividing. Divide by 4. It's okay. You can divide 0 by 4. It's fine. You're going to get 0. And since you didn't divide by a negative, no big deal. We just keep our inequality the same. Then we talk about this one. We're going to get rid of our constant. We're not going to flip our inequality because all we're doing is subtracting. Yeah, we get a negative, but who cares? We're going to divide, but we didn't divide by a negative, so we still don't flip that inequality. And if you look at it, you're going to see something kind of weird. On all the other inequalities we've had, they've been facing a different direction. These inequalities face the same direction. Hey, they're set up great. Verify that they're set up perfect. Variable on the left-hand side. Variable on the left-hand side. We solve them appropriately, no problem. We get the word and between them. So we are looking for a crossover. Now here's where it gets a little weird. We are still going to graph these. You're always going to graph inequalities, compound inequalities on a number line. Always. We're going to do that. I'm going to start with 0. This says I want numbers larger than 0 and including the 0. No problem. You're used to that. Now I'm going to look for -1. And -1's over here. I want numbers larger than -1. That's also pointing to the right. I also want them including -1. So let's make sure you get it, okay? Solve it like normal, no problem. We're looking for an overlap because of and. This says numbers greater than 0 including 0. This says numbers greater than -1 including 1. Now, what numbers work for both? I think we could probably agree that the numbers over here really don't make any sense as far as solutions. That doesn't really matter. If you plug in something like -5, it's not going to be true, and it's certainly not going to be true here. So all these numbers work in neither of them. The big question is this, and this is where students kind of get a little confused. It's not hard. You can do it. You can totally do it. But a lot of students really want to include this little interval. I want you to think about this little interval. What and means. What and means is the numbers that work in both inequalities. These numbers over here work in neither. These numbers starting here are just purple, just greater than -1, just greater than -1. It takes all the way to here to start including the numbers that work in 0. So if we're looking for the numbers that work in both, none, 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 just -1, just -1. That's why we're not double shaded. And then here's where we start getting double shaded. So this is one of the kind of a weird example, but if we're looking for the word and, the numbers that work in both inequalities start here, and they go forever this way. Numbers bigger than 0. That should probably make sense after I've explained it, that yeah, the numbers that are bigger than 0 are both bigger than 0 and bigger than -1. That's why we don't include this little interval, just the stuff that's double shaded. So our solution set, our interval notation for this, no, only one. That's not good enough for and. Both of them. Starts at 0 with a bracket, and it never ends. And you can test them too. Try some numbers if you're having trouble with this stuff. Try -2. It's not going to work in either. Try -1/2. Well, it'll work in this one, but it won't work in that one. Try numbers like 1. Oh, it'll work in both of them. And that'll give you a better hint if this is kind of weird for you. Now, what's even more weirder? Would this have a solution for or? Would it be the same solution for the word or? Or is different. I'm trying to get your brains kind of wrapped around it so that I don't have to teach as much in 2 more videos. What or means is numbers that work in either one of them or both of them. So for or, if we were talking about the word or, the only time you don't get solutions for or is when the numbers don't work in either. All these numbers would be excluded in the solution set for or. All these numbers would be included. Working in both is okay, like the car and the boat example. If you had both a car and a boat, you'd have one or the other. You'd have both, that's fine. If I said, hey, if you got a car or a boat, raise your hand. If you have both, you're still going to raise your hand. But so would this. So the numbers that work in either one of these or in both of them would be the numbers from -1 to infinity. And all, double shaded. Or takes at least one shading. That's interesting. We'll get there in about 2 more videos. Let me change this back so we don't get all confused. This solution set right here is just for and. It's double shaded. These are the only numbers that work in both inequalities. Therefore, they are the solution set for the word and. The next one, the last one. This one's weird. So let's solve them. We're going to go kind of quickly. You are at this point where you should be able to do this. We're not flipping the inequality. 0 divided by 2, no problem. Subtract 2, cool, we got 6, no problem. Divide by 3, it's not a negative, don't flip a thing. We got 2. We're going to put these 2 numbers on our number line. Let's start with 0. This says, hey, start at 0. This is organized correctly. Our variable's left-hand side looks really good. I'm going to the left, no problem. I'm using parentheses because I'm not including the number that makes the 2 sides equal. I'm excluding that. That's what parentheses do. Then I look at 2 and I go, oh, 2's, oh crap, look at that. 2's not over here. 2's over here. And I'm not going this way, am I? Oh man, I'm going that way. And then you look at how this is written. And we ask the question, are there any numbers that are less than 0 and at the same time greater than 2? I'll give you $1 million. You just tell me a number that's both, well, I don't have $1 million. I have like $5. I'm not even gonna give you $5, I'm sorry. But I got a 3-year-old, she's expensive. So let's, unless you're watching this like years later, then she's probably like 17 and I'm even more broke. Whatever. So I will give you money if you can tell me a number that is both less than 0 and greater than 2 at the same time. Do you have any numbers in your head that are both less than 0 and at the same time greater than 2? We can sit here all day. But the number line shows us that those numbers don't exist. That's what the word and is telling you. It says, look for the overlap. Look for the overlap. This is not overlap. This is nothing. This is not overlap. Just these numbers, they only work here. These numbers, they only work here. There are no numbers that work for both. Otherwise, we would have had an overlap. And in general gives you this. That's mostly. Now, we could get this, and you get this as your solution. Or here, and that's your solution for and. No problem. But if you miss, you go, oh yeah, the numbers, I got a double, I got an overlap. Ah, crap. You missed your overlap. There are no numbers that satisfy both this and this one. Are there numbers that satisfy this one or this one? Yes. The numbers less than 0 satisfy this. The numbers greater than 2 satisfy this. So for the word or, you'd have a solution here. You'd have all these numbers. You'd have all these numbers. The numbers that do one or the other. You don't need both to satisfy or. You need numbers that satisfy both inequalities for and. That's the difference between them. So here, for the word and, we would have no solution. The way you write that, you can write empty set, no solution, whatever you want to say, whatever your instructor. If it's me, I'd take the empty set, which is written like that, or just put no solution. It's totally fine. The main point is that you understand what and means. And means you have to have an overlap on a number line. You have to have numbers that satisfy both inequalities at the exact same time. That you can plug into both of them and they make true statements for both. If you've drawn it and you have no overlap, there are no numbers that satisfy that. No numbers in your solution set. It's empty. You can think about it. There's no numbers less than 0 and at the same time more than 2. That's the idea. That's all and really means. Other than that, I think we pretty much covered it all. We'll talk about double inequalities. It's a special case of and. It's going to go very, very quickly. It's not very hard. And then we'll start talking about or in 2 videos. And I'll see you next time.